Hey, happy Wednesday, superstars. This is Mr. Curtis and the fourth grade team at McLaughlin, and we're going to do some real world fractions today. So, as always, with a video, make sure that you press pause, take notes, rewind, rewatch as you need to. And today's video actually includes slides from the activity so we can kind of get going and put them together when we're learning about these word problems that we have. So here's going to be slide one, and you'll click on the YouTube link right here. It's not there yet because I haven't finished this video. And then slide two, we're actually going to do a puzzle penguin together on the video. And so then when you go back to your slide on slide two, you can just type your response in here, okay? And then on slide three, we have some problems here, and we are going to cover number 30 and 31. You'll still have to type your answers in these boxes on the slide, but we're going to do numbers 30 and 31, and then you'll have to complete the last few on your own. So let's get down to business. Today's focus is solving problems using addition and subtraction in mixed numbers. So that's what we're going to learn about today in terms of using them in word problems, and we're going to do some reviewing. So which of these two things represent a whole number? Here we have 1, 2, 3, 4, 5 out of 6. Looks like we have sum out of a whole, 5 over 5. We have 3 1/3, and we have 1 2/3. Which ones are whole numbers? Yeah, if you said 5/5 is a whole number, great. Whenever the numerator and the denominator are equivalent, that creates a new whole number. I invite 5 people to my party. All 5 kids came. I have a whole set of at my party. Which one is the other whole? Nope, that's not a whole. Nope, that's not even half, is it? This is a mixed number over here, so that's not a whole. Yeah, 3/3 is the same as a whole, 3 over 3. Good, so there's a review today. Now we're going to go to Puzzle Penguin. And this comes from our textbook in the Houghton Mifflin Harcourt for 6-6. So he asks us, this is a problem for my math homework. My friend says my answer is not correct, but I can't figure out what I did wrong. Can you help me find my mistake? Your friend, Puzzle Penguin. So the first thing we need to do is we need to look and see what actually is the problem here. Well, the problem is this right here. That's what the problem is asking us. 4 1/8, and we're going to subtract 1 5/8. So do you see what he did up here? He converted 4 1/8 to 4 9/8. And when he subtracted, he got an answer of 3 4/8. So I want you to take a little bit of time. You can press pause, write this in your note sheet, okay, write it in your notes, and then we'll go over this together. So push pause, and I'll see you in just a moment. Okay, so if you have finished, great job. Let's go ahead and look at the response. So he converted 4 1/8, it looks like, to 4 9/8 before subtracting. Now, when he subtracted these, 4 9/8, 4 minus 1 is 3, and 9/8 minus 5/8 is 4. So that part is actually okay. But what did he do wrong? Let's look. Well, to get 9/8 in this top number, you have to ungroup one of the wholes from 4 to get 8/8. So this should not be 4 9/8. It should be 9/8 for sure, because we're going to add. Sorry, I'm writing really small here. But what did he do? This should leave us with one less whole. He started and ended up with the same whole number. So if you're going to add, he added 8/8, and I'm going to do 8/8. Going to trade that so he gets enough to subtract to get to 9/8. So that part's right. But yeah, he forgot to subtract 1 from the whole number. So this leaves you with one less whole than you started with. So you'd have to change the whole from 4 to 3 like we did up here. This would get you 3 and 9/8 minus 1 and 3/8. And when I subtract, pardon me for taking some time here. So I'm going to now, oops, that's a 5, not a 3. I apologize there. So minus 1 and 5/8. And when I get that, I get 2 and 4/8 is my answer. And that right there should be a 5. I'm so sorry about that. So that was his error. He regrouped the correct way with the fractions, but he forgot to borrow from the whole number. So that's going to be slide 2 of today's activity when you get to Google Slides. Let's look at the next problem, all right? So here's a review of regrouping when adding and sums exceed a new whole. Again, we want you to take some notes. So we're going to use these fractions, these two mixed numbers, for both our addition practice and our subtraction practice. So take some notes in the left side margin of your notebook paper. And if you want to draw the models, great. If not, pay attention to the models. Do whatever the notes you feel is going to help you learn the best. So first off is we're going to add these fractions separately from the whole numbers. So I'm going to add the whole numbers first. So 4 plus 2 wholes gets us 6. That's great. And then 2 fifths plus 4 fifths would get us 6 fifths. And you can look over here, 1, 2, 3, 4, 5, 6 wholes, right? And then 1, 2 fifths, 3 fifths, 4 fifths, 5 fifths, and 6 fifths. Yeah, so that works. So that right here, though, is what we're looking at. That numerator exceeds. That's an improper fraction in the mixed. So could we just move over to create another whole? How many would we subtract from our answer to create a new whole? How many fifths would it take to make a new whole? So yeah, if you said that we need to subtract 5 fifths, right? That creates another whole, right? So this now is my whole. And if I'm going to trade those 5 fifths, right, for the whole, didn't I also add a whole? So 6 plus 1 now is 7. And then that 6 fifths with the traded 5 fifths that we converted for a whole should get us 7 and 1/5. And let's go ahead and double check that, okay? 1, 2, 3, 4, 5 whole, 6, 7 wholes plus an extra fifth. We simply just regrouped a whole for the 5 fifths. See how we did that? So now we have 7 and a fifth. Rewind that and pause it as you want to get that practice, but we subtract from the fraction and we add the whole. And why do we subtract 5 fifths? Well, because that was the pieces that we were talking about. That was the denominator, and that's what we really want to look at too, is the denominator tells us how many of that whole we're going to do. So 5 fifths. If it was fourths, it would have been 4 fourths. If it was 11ths, we would have taken 11 11ths and traded it for just one new whole. Okay, I know we're going fast, but go ahead, rewind and pause. Go to your next sheet of paper or the back side, and let's take those same mixed numbers and now use them in a subtraction problem. So 4 and 2 fifths. 4 and 2 fifths. Subtract 2 and 4 fifths. What do? We have a problem, don't we? This is a quick review of grouping to subtract when you don't have enough of a fraction to subtract. And what I mean by that is I have 2 fifths right here to start with, and I'm subtracting 4 fifths, and I don't really have enough, so I'm going to have to do some ungrouping. So what did I do? Write this equation down, and then we'll do some work with it. Now, I've already written down the ungrouping, the equivalent of that. So what I did was I took those and I'm going to just subtract a whole, and I'm going to cut that whole up. Really, I'm going to trade a whole for 5/5. Last time we did the other way. We subtracted 5/5. Well, this time we're actually going to do this. So with my red pen, I would like you to copy and match me with your pencil. And we're now going to take 5/5. And what we're going to do is we're going to add 5/5, but we subtracted a whole. We subtracted a whole. That gets us now to 4 minus the 1 whole is 3. 1, 2, 3. But we really didn't just subtract, we regrouped. And I added 5/5 because that's what the denominators we're looking at. So we have 5/5 extra. So now we have 7/5. 3 and 7/5. Do I have enough to subtract now? Looks like we do. We have 7/5 and we're subtracting 4. So we have enough fifth pieces to subtract. Let's go ahead and do the subtraction. Let's start with the fraction pieces. So here's what I'm going to take away. Okay, these are what I represent. So I'm going to take away 1, 2, 3, 4/5. So I got to get rid of 4/5 up here, right? So I'm going to take away 1, 2/5, and I'm going to, let's see, 3/5 and 4/5. So I'm gone with those. Those are gone. Now I'm going to subtract my whole numbers, which it's told me to subtract 2. So now I have to take 2 away. 1, 2. And what do I have left? Well, I've got 1 whole. And then how many fifth pieces do we see? 1, 2, 3. 1 and 3/5. So we ungrouped because we didn't have enough fifth pieces to subtract. We took out a whole number and we just basically cut that whole number into fifths as a trade. So last slide for me before we get to your work is these two problems. You'll see them on slide 3 of today's activity. So it says in the book here, write an equation, then solve. So I'll read the problem, and I'd like you to give yourself some space to do it in your notebook, write your notebook. And it reads, number 30 says, Daniel spent 1 1/4 hours playing soccer on Saturday and another 3/4 hour playing soccer on Sunday. So not quite a whole hour on Sunday. How much time did Daniel play over the weekend? So when we write an equation, that's what that is right there. So go ahead and type in or write in 1 1/4 plus 3/4. What do you get? Yeah, so if you remembered that 1 4/4 can also be regrouped, we can take that 4/4. That is a correct answer. 1 4/4 works. But if we have a fraction that becomes a new whole number, we actually have another extra hour. So 1 hour plus the 4/4 gets us 2 hours. And like I said here, don't forget to include your units when you're writing, especially word problems. So we have 2 hours. Now number 31. This one's a little tougher. A pitcher contains 4 3/8 cups of juice. Antonio pours 5/8 of a cup into a glass. So not a whole glass. How much juice is left? Again, handwrite your equation. You may do it vertically if you want. 4 3/8 subtract 5/8. This is just like the last slide where we don't have enough. So I'm going to go ahead down here and show my work. You're going to match me. So I don't have enough. I have 3/8, but I'm taking away 5/8. So I'm going to create another, I'm going to subtract and ungroup. So I'm going to take a whole away. So now I have 3. 4 minus 1 is 3. But if I'm going to subtract a whole, I better add its equivalent of a whole, which is, in this case, 8/8. And why do we use 8/8 and not 7/7 or 3/3 or 2/2? Because that's the fraction that we're using. That's the denominator that we're using. Okay? So now if I add the 3/8 plus the ungrouped 8/8, I get 11/8. 3 and 11/8. Now if I can do my subtraction, I'll do my fraction first. What's 11/8 minus 5/8? Right, it's 6/8. And then what's 3 whole minus no whole? Because he didn't drink a whole cup, he had less than a whole. So if your response is 3 and 6/8, congratulations, that's how you do it. As always, McLaughlin Superstars, when you see a problem that you get a little confused on, press pause, rewind, go over your notes, and make sure the important thing is not that you get it right, but that you keep battling to find out the right answer by working over and over and using your notes to help you get through it. Hopefully the activity today will be a good one for you today. Please email your teachers if you have any questions or in the comments on the slide. Remember, you're going to type your answers in the slide. They'll be over here. You'll type your answer in the slides. Don't forget to do that. We hope you had a great day of learning, and we'll see you later. Bye for now.